Yeah, my microphone is on. Let's see. Hello everyone, welcome back to Learning Kotlin Live episode 13. So today we're going to Hello everyone, welcome back to Learning Kotlin Live episode 13. So today we're going to go back to revisit that question we left yesterday, which is a sorting problem, which is which is a variation of the traditional sorting problem. So the variation. This is the variation. It has whenever we see a -1 in the array, we need to treat it as blocking items, which is described as tree in this problem, and we need to just place it there as it already is, and just skip it when we sort it. So yesterday we have a solution which is based on bubble sort, which I can give a really brief introduction about what we've done yesterday here. So yesterday we have a two-loop, two-layer algorithm, which is ln square, and in the first loop we mark this as unsorted, the last item that is unsorted, and later when we do a bubble in this area, the whole array from 0 to the last, we can promise that the largest is always of all of these every item in the array would be visited at least once, and because every time we swap the item, if it is not ordered properly, so the largest item would definitely be bubbled up from somewhere. In this case, it's 190 because it would be swapped 190 and 170, and because it is swapped, the next check will still have the larger one. So the largest is going to be bubbled up to this position in one iteration, and in the next iteration we treat the subarray from the first item to the item before the last item, and again we have the item before the last item in the original array sorted. So now after we have iterated from a.last index down to 0, we will have done the whole sorting process. So what do we do in each iteration? We take a look at in every visit of the subarray, we examine every pair, And so we start with first index equals to 0, which points to list item. And then we iterate up. We first check these two items and then these two items. And every time if we, let me see. So, oh, actually, I think there's a flaw in this algorithm. Actually, I believe, strongly believe, it is only because the test data is too naive. So, I don't know. But what if? This is what I'm looking at. What if the first item is -1? Because we assume that this is it. Because we only swap when there is a larger one. So even though we don't handle -1, so if -1 is not marked as -1, it's actually marked as like, because the constraint is 1000. If it is marked as 1001, then this algorithm is going to be incorrect. Why? Because for this case, we only we will examine this -1 and 150 pair, but actually it shouldn't, because so actually we should have done this another iteration here. So this is the thorough solution, which is kinda accidentally correct based on the dataset implement representation, because we represent values in -1. -1 means trees, and if the value of the height can be negative, or if we don't represent it with this -1 and use 1001 instead, then the data will work. Won't work. But this is also a demonstration of how sometimes something that looks incorrect can actually speed up the processing of the algorithm. So we should always take care of one thing, that the constraints is the core of an algorithm. So both the data representation and the constraints, they build up the problem that we are going to be solved. So if the problem does not state like I mentioned, 1001 means a tree. If it does not state that, then you should actually implement it as fast as you can. You should, because constraints are what makes the problem different. So for this case, but however, what I'm trying to seek in these practice is the general idea. So I still feel like this is the correct way to do it, because because that is also giving us some flexibility in solving problems. So okay, let's get back to where we were. So let's first submit this one to make sure that I am actually writing the correct code. I mean, my claim is correct. With these, it is still correct. Oh, there's a compile error. Let me take a look. Because in for loops, it's value, I guess. Can we make it var? I think so. Yeah, I think we have done this before. Let's make it a var. So actually it's the O and square. var is not allowed, val cannot be reassigned. So how can we have a var in? Is it not possible? For loop. Var. Let's take a look at this one. Mutation of loop index variables, and we have no plan to do it. Makes sense. So then well, this makes things more complicated then. In a nutshell, no, I don't mean in a nutshell. I mean, to make things simple, we can do this rail. Let's call it rail. Maybe no, because oh, this is complicated. So let's use a var here. Var first index of pair equals to 0, and var second index of pair equals to first. Well, we're not going to assign it. So while this makes things simpler, of course. Second index of pair. No, this is not initialized. First index of pair is smaller than last index not sorted or equal to. So so we're going to check every pair here. While first index of pair is smaller than last index not sorted, first index of pair is plus, and then we get this, and we do a check and swap here. And at the very end, we make first index of pair equals to second index of pair. I think this will do the trick. Var. Okay, let's initialize it to don't care. Initialization don't care. How can I don't know. How can I like express it as late init? Am I doing it correctly? Late init. No, modifier is not allowed on local variables or primitive types. So no, I thought this is going to work, but no, not for local variables. You have a type in each. Okay, so that's the trick. So not for primitive types. Yeah, makes sense because it needs to be pointed to some item, but that's Yeah, I don't like this syntax, but maybe this can be improved in some future languages. I don't know. Because, yeah, I hate it when we need to initialize it into something here. Let's submit it. Okay, I have already spent like 15 minutes in the previous answer. So, well, as I don't know if we have the time here. I don't know why do we have an upvote here? That's thank you for anyone whoever. Thank you for whoever have upvoted this. That's amazing. Oh, actually, someone upvote everything here. I don't know. Not me. Not me. Someone upvoted everything before me. That's actually pretty weird. I don't know what's happening here. Or is that some arrange or? Yeah, this is so weird. I don't get this. I don't get this at all. But oh, this guy is practicing Kotlin too. Hi, friend. So let's make it based on pivot. I mean based on quicksort. So if it is based on quicksort, we don't really need this. So sort by height. Let's do this. We want this function sort by height, and because we want to do a quicksort, which is kinda solving with the divide and conquer way, we need a beginning. Oh, this is not Kotlin style again. Beginning, integer, and let's just call it begin. And a list. And we're going to do the middle as pivot way. And we need the mutable list, which is A. So, we're going to do something like sort by height. 0 to where's the end? A dot last index and A, and we're going to return A. So this is the, let's copy this somewhere else, and yeah, comment it out. This is the bubble sort style. No style. That's it. So let's remove these items, and here we go. And we're going to pick the pivot. So actually the hard part of using the hard part of writing the I don't know, what am I trying to say? The hard part of writing a quicksort style algorithm for this is actually picking a pivot, because if you pick the pivot, and so we talked about quicksort a little bit yesterday, but I think we have not go through it yesterday. So let's take a look at it. Give me the English version. So yeah, basically, yeah, I think we did go through this. when we want to sort this range, let's talk about this range now. We pick a pivot in it, and then put everything that is larger than the pivot to the right of the pivot. We swap them, and yeah, look at how we swap. We take a look at the two items on both ends. So let's look at this first item. We pick a pivot, and then we swap. And yeah, that's a pivot. That was the first pivot, and we put everything that is larger than this pivot on the right, and everything that is smaller on the left. But what if we have picked -1 as a pivot for this case? That is something that is really hard. So a way to solve this is simply to do a randomized pivot. I mean, we can pick the last one as a pivot and swap it. We can't really swap it actually. So that's difficult. So let's assume the strategy is we're going to pick the middle as the pivot. No, we're going to pick the rightmost item as the pivot. Wow, this is not solving anything actually, because the rightmost item can still be a -1, but that's a bird. But we know how to take the second priority item, because we know that if it is -1, we don't need to sort it, and so we can take the one that is smaller than on the. I mean, that is if the last item is k, we can just take the k -1th item. So we're going to pick the. We're going to pivot, which is of type int equals to x. It's actually pivot index equals to end. And while is larger than 0 and actually it's begin. And a pivot item does not equals to -1. We're going to it's actually this. And we're going to sort by height. Pivot index. Let me think about it. So we have two parts. So let's call it last item index. And index. Valid and index. That's self-explanatory. And at the end of the list, we check pivot and sort by height, pivot through valid and index. Let's also do this valid begin index just to speed up the algorithm. This can be way faster than, so this is smaller than end. Valid begin index to vivid. So um what I am going to do is to that's quick. So if we simply swap the item in between, it is going to be, is this even Quicksort? I don't know. This is not a Quicksort I've learned, but it's just look exactly like this. I mean, we look at each pair in it and swap it if it needs to be swapped, and we pick the item in the middle as pivot. So we need an example here. So for instance, let's use 1, 10, 8, 6, 3, 4, 5, 2, 7, 9. Let's use this as the case. So for instance, in the first run, we do this. Let's skip that 10 because it looks ugly. 1 and 9 because 9 is larger, it's still at the back. 7 and 8 because 8 is larger, so it's swapped to the end. And then, oh no, this is not going to work, but yeah, 2, 6, 3, 5, and we have this 4 here, and 4 is the pivot. Is this true? No, because this is still on the left. So yeah, we cannot do it that way. We still need that pivot. But how do we? I'm wondering how do we? I need to shoot a code. Yeah, it's swapping a high with a high. Okay, this is the Lamuda partition scheme, and there is a Horde partition scheme. Yeah, this is the one that I'm familiar with. Loop forever, like. Yeah, we swap the items that does not fall into that case. So yeah, it's a little bit challenging to solve it that way here. Is anyone watching? I think I'm using too much time. No comments, but there is one audience. Hi there. Feel free to say hi in the channel. I think I've enabled a live chat. So let's take a look again. So the hard problem is still how we're going to pick a valid pivot here. That's hard indeed. Let's do the one behind and one in the front method. That's a little bit. So that's right. Another function for this function pick pivot, which takes the begin, which is also an integer, and end, which is yet again an integer, and the whole list. I'm only writing it and it returns integer. I'm only writing this in a separate function because for clarity. So we pick the pivot as the pivot index equals to let's call it zigzag pick pivot, and the pivot index equals to begin plus end divided by 2. That's actually a var. If where's that a pivot index equals to 0, no, -1, that's a tree. Return. Oh, this is so ugly, but I like it. Begin. So how are we going to zigzag? Okay. Let's call it val sum equals to begin plus end, and pivot index is sum divided by 2. If a pivot index is not equal to, we have the pivot then, that's a valid one. Else let's look at the sum. If the sum is, oh actually this is not going to work. If we need a generator, and it is called boolean, and it is called begin toward begin from, maybe make it so simple, cut and first, and it is of type boolean. Should I spell it boolean or boolean? Kotlin primitive types. Where's the boolean? It's called type boolean. It's large, capital case B. If cut and first, and let's give it a true. It does not matter anyway, actually. If cut and first return zigzag big pivot, begin, oh actually let's just do it this way, begin, oh no, not exactly, begin and -1, and what's that? What's it? Oh, I think we can use the Elvis. Is that Elvis? Val digsum diff begin equals to if that's a Kotlin tannery. I always forget it's the if, but I can't remember the style it has. If, okay, if else, and bracket. Else, do we need the, no. If cut and first 0, else +1. Val diff and equals to if cut and first -1, else 0. And then we can do this. Return zigzag begin plus diff begin and plus diff end and not cut and first. Yeah, and if so, we need a check here. If and equals to begin that's a special case. Let's call it, I don't know, where do we place this? These final event file constant. No what? No pivot. Let's call it no pivot. It's actually index. So we haven't got it yet. Okay, we're taking a lot of time today. Pivot index, pivot index. Yeah, we need a partition first. That's actually a partition part. So let's call it partition. does this true come from? A low high, A low P, A low, yeah. That's also P. It returns an integer. So this episode is going to be longer than we usually is. So feel free to let me know if you have some time constraints so we can continue tomorrow. But I kind of feel like I'm going to write the whole thing because makes it complete. No pivot. Why do you get a gift? That's so late. Actually, this quicksort may be a little bit slow because we're using this zigzag big pivot index method. So maybe it's not as fast as we expected, but I'm gonna finish it anyway. Begin and a true. The pivot equals to pivot index, and I'm writing it in Java style again. Pivot index and if we're done if it's no pivot. If it's not, then we need to do some work here. So var left, let's call it left, equals to begin. Var right equals to end. And I think what happens in the very end of it, so it returns why? Okay. Wow, the hard part again is we might pick an unequal pivot. So that's unstable. Very unstable. So let's call it initial pivot because it might change at the very end of the iteration. Initial pivot index is not equals to that's a var. Let's call it pivot index then because it can be changed. happen if there is no pivot? It means you can return anything. Wow, this is nasty. This is really nasty. I started to doubt if we really need to write this. As long as we have an audience, I'm going to write it. Okay. So, why do I say it is nasty? The reason is mostly because the pivot index is moving, and traditionally when there is a sorted item -1, well, maybe traditionally when there is no -1 cases, then we can choose any of this as pivot, and they will be, and because they are sorted, well, maybe not that nasty as I have thought, but yeah, maybe not that nasty. I was thinking that the -1 is going to drag the performance, but maybe not that. Maybe that's not the case. It actually can be speed up with other algorithms, just not Quicksort. So, there's actually no pivot. Just simply do the AND. Return AND. So we don't need this anymore for this case, because we still need a pivot to decide where is the middle point. I mean, where do we partition it into, because we need this pivot index as input of sort by height and of these two subarrays. How do we break it into two subarrays? So we still need these. It's going to zigzag, 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 I believe. Is it? No, it's not going to zigzag. It's going to zigzag this way. I mean, it's not going to zigzag like larger and larger. So no, this is not a good solution at all. Oh my gosh. Okay. Okay, that's really frustrating. I'm going to, okay, so this again is incorrect. We need this to be not true. We need a, not a boolean here. Offset. It's an integer. Offset 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 is larger than 0, smaller than 0, else 0. So this way we're going to zigzag. Well, next offset equals to so this is hard to explain. We have this offset here. Let's see. Let's assume that we have a rate like 3 minus 1 minus 1 minus 1 2. So with zigzag pivot index, we have the begin equals to point to here and end point to here. Then we add the sum as begin plus end, which is 0 and 4, and then the average is 2. That's here. And because it's minus 1, we need to zigzag. So we then first, because the offset is 1, is it 1? It's 1, so we have this diff begin is offset. Because offset is 1, so this is 1 and 0 here. So the next offset is, so we then seek begin just, we seek 0 plus 1, which is this and this. We seek the one between this. And the next offset is minus 1. Oh, it's actually am I correct? I don't think so. Oh yeah, that's it. If it's smaller, then the next one is, yeah, increase it and flip it. I don't think it's zigzagging still. Oh my, this is hard. Yeah, it's still not zigzagging. How do we write this zigzag thing? Okay, I think I need some time for this problem, so I'm going to just stop here and take a look at the next problem, maybe. Verse parenthesis. Okay. Okay, this is simple, but we're going to solve it tomorrow. So yeah, I think we need more time for the quicksort alternative that I just proposed, because it's a little bit complicated. So yeah, I'm not sure if I'm going to take a look when I have some free time later. And so the problem is, oh, oops. What I am seeking to do is, if we pick this as pivot, and because it's invalid, so we then pick this as a pivot, and then this one, then this one, and this one. But this zigzag pivot index function implementation here is incorrect. So I thought that by changing the begin and end, it's going to zigzag, but not exactly, or at least not the way I'm changing them. So I need more time in doing this, because if I -1 here, I was thinking of if we zigzag outside like this, and then this, and then oops, and then this two, and then this two, and then this two maybe, and these two, then we're going to zigzag successfully. But no, I'm not exactly. I need to change the implementation. So yeah, please allow me more time to look into this tomorrow, and I'm sorry for that, but yeah, we're gonna see tomorrow. So see you in the next episode 14, or maybe after episode 13 of Learning Kotlin Live. So see ya. But I hope that even though I'm writing the algorithm incorrectly, I do use some Kotlin style that was introduced recently. I hope you still enjoy it, really. So see you tomorrow, and that's the end of Learning Kotlin Live episode 12. Bye bye.